Okay, so here is the last question from the CWC exam, mechanics question on a slope. First thing we always need to do, obviously, is do a nice big sketch. So I've got a big sketch here with the particle sitting on the slope, and we can fill in the weight, which is going to move directly down. And then we can resolve that to parallel and perpendicular to the slope. So there it is, mg cos 40 perpendicular to the slope, and mg sine 40 parallel to the slope. I always redraw the force that's parallel to the slope actually coming out of the particle, so that will be going down the slope. Because we know that this particle is travelling down the slope, it's not going to have any movement perpendicular to the slope, which means that it's in equilibrium in that direction. So these two forces must be equal. So we can say that the reaction force of the slope onto the particle is also mg cos 40. We were given the coefficient of friction as a half, so we can say that our F max is going to be half mg cos 40. So that's the diagram all set up, and we need to make sure that we are clear that we've worked these two things out. So the reaction force mg cosine 40 and F max half mg cosine 40. What we're asked to find is the acceleration, and we already know the force going down the slope. We also know the mass, so it would suggest we need to use F equals ma and substitute everything in, and we get this equation here. Straight away we can see that every term has got the mass in it, so we can cancel the masses to get this equation here for A, which we can pop into our calculator, and then remember that we've used G as 9.8, so to two significant figures, so we should give our answer to two significant figures as well. So that's part A. Part B asked us to find the speed of P at a point B further down the slope, and we've already got quite a bit of information. We know that the distance between A and B is 3 meters. We were told that the particle was held at rest at A and then let go, so the initial velocity was 0. We've just worked out the acceleration. Do try to make sure that you keep the whole value of the acceleration in your calculator to use, rather than just using the 2.5 that we rounded our final answer to. And then it's the final velocity that we're looking to work out. So we can choose the appropriate Suvat equation, connects those four, sub in all the values that we know, and we see that v squared comes out to be 15.274, etc. We can square root and again write our answer to two significant figures. And that's it for the mechanics question. Quite a nice one this time. Okay, thanks.